Hello everyone, welcome to Peer Learning for You channel. Today we will have the session Python Basics Part 4. This will be our final session on Python Basics. If you have not seen the previous parts of Python Basics, please feel free to check that. I will add the link in the description. Apart from that, you can check other videos posted in this channel. I will add them also in the description. Today mainly we will go through magic methods, decorators, and then what is the significance of the underscore main method. So let's begin. Hi guys, so let's start with magic methods. uh, so for that we need to start writing some class. Let me start with a sample class. Okay, it can be anything, and for the timing let me make it blank, and let us try to see like create an object of this class and try to print this class. Okay, so before that let me show you like what are these magic methods are. So if I do a dir over this, let me run it. So you can see the output. You'll get this underscore methods are all magic methods, and I'm going to explain few of them. To get the complete list of these functions, you can go to the docs.python.org, where you will get the list of all the underscore methods and you will have more details about them. So I'm going to explain you a few important magic methods here. One will be REPR, one will be STR, and then I'm going to show you some operator overloading through magic methods. So let me print this object. Okay, let me print this obj1 and let me show the output. Yeah, so you can see the output is this. So it's not a very user friendly output. So if you want something else, for example, you want to display the property of the sample class or the object, you need to have like overload or override the magic methods. Now there are two kinds of magic methods in Python which actually display your content, that is REPR and STR. So first let us create some attributes of the sample class. So let me define the init method, and maybe it is going to take few inputs, for example age and for example name and age. Okay, so let me take this too and I will put it in my attributes, something like this. Okay, so now let me create this REPR. Okay, so REPR and will be self, and let me print this REPR. Let me print something like this is coming from REPR method. Okay, so let us see. I just need to initiate this with few parameters. Okay, so if I do a print object1 and I have only defined this REPR in my sample class, it's going to print this REPR content. So let us run it. Let me clear this. Yeah, let me run this. I'm getting an error here. It's telling str. Okay, sorry, it's not a print. It should return. It should return a string. Okay. So yeah, so you can see when I run it, it is printing me out the REPR part. This is coming from the REPR method, and if you declare the str method, str method. Okay, and then if I run it, and now you can see it's not printing the REPR, it is printing the str. So by default, if you have not defined your REPR and STR methods, by default, the object actually uses this REPR method to display the content. And if you have declared both the variables, both the parameters, then they actually follow the STR method. So keep that in mind whenever you're printing anything and you want to make you want the output to be more user friendly and user readable. You can go with this STR, and the REPR is kind of a representation of the object. So I'll show you the difference between these two now. First, let me tweak this method. So I just want to return a more user friendly output. So it should be self dot name and self dot age. Okay. Okay. So let me print it out, and you can see it got printed. So if you print this object, it's going to call this function and going to print it out. Now, what is the difference between REPR and STR? I can understand that by default it calls the REPR, and then if you declare both the REPR and STR, it's going to call the STR after that. But then why we have two methods here? Why not one method? So for that, let me go to the terminal to explain you more in detail. Okay, let's start with Python 3. Let me create a class. Okay, class sample, and for the time being, make it pass. Create an object out of that class, and let us try to print the object. Okay, so I got this, and if I print the object directly, like in the terminal, I can see this. So let us create a class with the RPR and the STR methods. Okay, so this should be the REPR self, then it should return this is REPR output. Okay, and then let me define the STR one. Again, return this is STR output. Okay, so I've created this class. Now let us create an object of this class. Got it. So now if I print this object, I will get the output from the STR method. This is STR output. That's fine. That we got from the Visual Studio Code also. But see, if I print this object directly in the command prompt, I am getting REPR output. So this is the significant difference between REPR and STR. REPR actually helps you to represent the object in the prompt itself. So it's the object representation of your object, and string is more about representing the variable in a more user-friendly manner, in a more printable manner, in more human manner. But the object itself will get represented if you have defined the REPR, and to print that object as a printable text or string, you need to use STR for that. So that's the difference between REPR and STR. So let us see another example of the add function. Okay, so let me show it here itself. Like for example, if I add two numbers, 2 plus 3, I'm getting 5. But if I add two strings, for example, SA plus, I'm getting Sabby. Okay, so you can see, depend on the variables, the add operator changes the operations. So if it is an integer, it's going to do a mathematical addition. If it is a string, it is going to do concatenation. Okay, so why this add operator behaves differently for different objects? Because they have internally add magic method that actually playing the trick here. So let us do one thing. Let us create a magic method here, which is add, and let us like take input as the self as well as uh, uh, another or another object. Okay, another obj where it's going to do the addition, with whom it's going to do the addition, and let us return uh, self dot age plus another obj dot age. So it's going to add both the object's age and it's going to return the uh, addition of those ages. So let us create another object obj2 sample class. It's savvy1 and let us make it 100. Okay, and let us see whether we can get 110 out of this or not. So if I print obj1 plus obj2, okay, and let us see the output. And you can see the output is 110. So this is all about magic numbers. So now we are going to the next topic, that is decorators. So let us continue with decorators now. Let us go to the IDE. Let us create a class. For the time being, let me pass it. Okay, and create an object out of it. So to understand the concept of decorators, you need to understand few things here. So let us create a function known as func1. Okay, and it does nothing. It just prints the function. Okay, now if I want to print it, I can call it like obj1 dot func1, and it's going to print it. So this is func. Okay, so think of a scenario, you have hundreds of functions and all those functions actually share some common steps. For example, they all print the statement called this is common. Okay, so to do that, what you can do is like you can create another function. For example, the name of the function can be common, and you can actually print common here, like this is common, and every time you come to func1, you should call this function self.common, so that it prints the common and then it prints your function. So in all of your functions, you need to write this self.common. Okay, so that whenever we call this func1, we get the common output. But there's a concept called decorator in Python, which actually helps you in this kind of scenarios, that you just write your own function and you don't have to worry about um, the the method, the common method. Okay, you can have this @sign, and that's it. In the common function, you just have to return the existing function. So return self will always return the self object. So if I run this, I will get the same output. So this is the concept that we have seen in when we were going with the inheritance, where we was looking for class method and static method. We have used this @sign and those decorators. So decorators are very useful features in Python. So let me show you some other features of decorators here. So for example, uh, you have some properties known as for example full name and last name. Okay, and let me take those into a variable self dot l name equals to l name. Okay, and then let us give some input here, like savvy some other. Okay, So fname lm is sorted. Now, for example, there's a requirement that you have to print your full name. So you can do something like this, right? You can do something like this. You can print f obj1 dot fname, and then you can have this obj2 dot fname, sorry, 1 dot lname. Okay, and you can print it. So this is going to print Chabi Samadhar. Okay, and let me comment this out. Okay, so let me comment this out. Okay, that's fine. So now if I want this full name as a kind of I don't want to print it explicitly. I just want to call some property, and it should give me this kind of result. So for that, I can actually create a function known as full name self, and then here actually I can do the same thing with what I've done below. Like I can take this print and I can put it in the method above. Okay, so now if I call this object like obj1 dot full name, I'll get the name. Okay, so I got the name. But if I want to use it as a property, okay, I just don't want to call a method, I just want to use it as a property. So how to do that? You can do that by the decorator. So you can have a at the rate property. Okay, and then once you do this at the rate property, you don't have to mention this function. You can access this full name as an attribute. So you can see the name got printed. Yes. So now we can use this full name as a getter. So this at the rate property enables this full name function behaves as a getter method, which actually gets the full name from the class and uh, prints the value. Now if I have to set this full name, for example, I want to set this full name with some other name. Okay, equals to for example, I want to put my complete name, and here goes my title. And when I run, I'm getting an error that this attribute error can't set attribute. Okay, so for that there is another property like another decorator property which we can use, that is at the rate full name. The name should be same, full name dot setter, and then we can have the same method full name self, and then we can have the parameter which is kind of the full name or f name or name. Okay, let's not confuse. So here what we can do, we can split the name dot split with a space, and then we can create this, like we can make this f name and self dot l name equals to l name. Okay, so in this way you can set a variable. So now this will work, and after that if I print it obj1 dot full name, I should get the updated result. So let me clear it out. Okay, yeah. So, and you can see it got updated with this values. So you can have a deleter method also out of this. So you can have a deleter decorator full name dot deleter, where you can delete this variable also, like not delete, but you can have the concept of deleting it. So like we can print something like method got deleted, or let us don't print anything. Let us just make this name and end name as blank. Okay, so once you do it, you can actually access this property through the command called del, and then you can have the object1.full name, where both of your parameters will be set into blank, and then if you do a full name, it will be blank. So let's see it, and you can see it printed blank. So this is the kind of beauty of decorators, and hope you guys understood it and you can use it in your coding. Thanks for watching. So now let's start with what is main. Okay, you might have seen this in most of the packages you have kind of downloaded or used. So I will explain you what is the significance of this main method, or why this is very important. So let's go to our IDE and try to create few files. So I'll create the first file name as first module, and I'll create another module called second module.py. Okay, so now in the first module, let us print this part. Okay, like let us print this name thing. Let me see what is there. Let me clear it out. Yeah, so when you print it, you will find that the output is main. Okay, and if you actually import this first module, I have shown in my previous sessions like how to import a module. So it should be something like this: import module and first module. And if you import it and try to run it, here the output is first module. So what is happening actually? So suppose there is a function. Okay, there is a function call which is kind of uh, printing from where you're calling the function. Okay, and here you are printing it like this is getting called from use this name part, and if you call this print function, and let's run it from the first module first. So let me call it from the first module. So you can see the output is this is getting called from main. But when you go to the second module and try to import the first module and run it, the output is this is getting called from first module. So I think you got the difference between them. So by default, this name is main when you run it locally, but when you import it in some other file and then run it, it will show you the module name or the file name. Okay, so this can be an issue because like suppose there are some methods or some classes you have defined and you don't want them to run. Okay, you want them to be called explicitly. For example, if I created a function called print me, I don't want this print me to get called implicitly or automatically whenever I load the module. It should happen that I load the module and then explicitly call this print method. But then how to test my function? Like if I write some function, I want to test it also, and I don't want to delete that code and then send it to the to someone to use it, because they might not be aware of how to use it. So I want to show them the how to use my methods also, and also I don't want to run those part. So how to deal with that? It's like putting a condition like if name equals to main, then call this function. Okay, then print me, then call this function. So what will happen is that whenever I'm going to run this method locally, I will run this print me automatically. This is getting called from main. Okay. But whenever I will import this first module in any other file or a second module, this method will not get called implicitly, because you can see nothing got called. So let me clear and show you again. Yeah, so nothing got called, because here it will check and it will come here, the name is not main anymore, it's the first module, hence it's not going to print this. So you can actually print this through first module dot print me, like calling this method explicitly. This is what I want. So if I run it from here, I'll get the output, this is getting called from first module. So this is the importance of comparing the name parameter with the main, so that you can have your unit test cases and junk code or test code here in this section, and you can keep all your methods for exposure, like for consumption for the from the other modules, and all your junk code can be a reference, so that anyone who is kind of consuming your modules should know how to use your modules. So that's it from me. Thanks for tuning in, and we will have more advanced Python sessions down the line. Thanks for watching this video. If you like this video, please give a like below, and please do subscribe to our channel for similar content.